Today I'm building the computer I would have dreamed of back in 1981. This isn't a restoration, we're starting from scratch with brand new PCBs, modern components and a custom 3D printed case. It's called the ZX81+38 and it's the ZX81 Evolved. Not your regular good only for holding doors open 1981 wedge. This will be what is considered to be the ultimate ZX81. Something actually usable. Plus, I'll be adding a little bit of retro bling to go along with it. The humble ZX81 with its much derided microwave oven control pad keyboard and essential RAM pack, which would ruin your day if someone sneezed in the next street, is still one of my all-time favourite computers. Built by Sinclair as a follow-up to the ZX80, the ZX81 found a place in the market at a price no other computer in the UK and possibly the world could compete with. This was Sinclair's special skill, taking a potential product, stripping it down to the bare minimum required to actually function, package it in a nice stylish black case, and then sell it for a price that was affordable for normal everyday people. My own ZX81, which was bought second-hand from my best friends Jason and Marcus by my parents for the princely sum of £20, was my first computer. It was possibly the first computer I'd ever touched or even seen in the flesh, and I adored it. I still do. I never upgraded the RAM, managing to eke out my entertainment with the included 1024 bytes of memory that came as standard, but that didn't hold me back. I'd spend long evenings after studiously not doing my homework, tapping in raw machine code listings from computer magazines, and sometimes, if I was really lucky, they would even work. I've heard many similar stories of fondness for the tiny but lovable microcomputer. It seems to have been many people's first experience of computing, which given its price isn't a great surprise. So the ZX81 will be the subject of this video. And what I'd like to do is build a brand new one from all new parts. And one of the best ways to go about this is a project called ZX81+38, which was created by a clever retro tinkerer called Mahjong back in 2022. There have been a few builds of this already on YouTube, but I'm hoping to do one aspect of this just a bit better. We'll get into what that is a bit later. My board folk friend Julian Brown created a special edition of the ZX81+38 with my channel and the befriending scheme logos. These were organised last year by Fuzzy Lee, who sold them off to raise money for the befriending scheme. I have a couple of those original boards in purple, which was the colour of choice at the time, but this time I wanted to build to a theme. So I got my channel sponsor PCBWay to create some new ones for me. This is as simple as uploading the Gerber files to their website, selecting the colour, which in this case is white, and the final change will be to upgrade the finish to Enig for a little extra sparkle. This is a good move on any board where you have edge connectors. Regrettably, I forgot to select the option to chamfer the edge connector, so I'll have to ease the corners on this with some fine sandpaper on a block later, just to prevent damaging any peripherals being plugged into this machine. I also ordered a matching set of Don Superfo ZX Spectrum mechanical keyboard PCBs, and less than a week later these wonderful boards arrived. It still amazes me that you can order PCBs and indeed all of the other services that PCBWay provides from the other side of the world and have it delivered to your door in such a short space of time. But I'm going to need more than a few posh PCBs to make a working computer. Key switches, keys, components, more components, a few more components. These ones are taped to sheets of A4 paper with the designators ready to be placed. I only did the obvious smaller things like caps and resistors. The chips will be better off stored in their anti-static bags for now. Anyway, enough chatter, on with the build. Diodes first. I figured that because some of the resistors will be stood on their ends, that diodes would be the lowest components. There are only a few to fit on this PAX board. After this blue jobby, a load of 1N4148s near the keyboard connectors. Resistors next. Unfortunately, I didn't spot on the bill of materials that there were some much smaller resistors designated in certain positions. Fortunately, for a good bunch of them, I happen to have some in my stock, thanks to a kind gift from my good friend Henry. The components on this board are seriously crammed in, so I'm going to have to be creative with some of the larger resistors in these small footprint holes. I'm also tempted to solder in SMD components here instead. Right, resistor soldering montage. Enjoy the music. Okay, that's the resistors done, except it's not. There's a few resistor packs or resistor networks to be fitted too. Onto the caps. The caps to be placed in positions C1 and C2 are 15 picofarad, which is tiny. This is my old component tester, which you can see can't measure these. And this is a new one which was kindly bought for me from my Amazon wish list. Let's peel. Oh, well, that was disappointing. This tester can measure this component. Thank you whoever bought this for me. There was no gift note included. That's all of the caps apart from the decoupling caps. And that's all of the ceramic caps installed. There are still 2 electrolytics to fit later. Transistors next. And now the crystal oscillator, which should be super easy. Just a through hole part, easy peasy. Wait, there are no pads on this side of the board. Let's improvise. Some blue tack to hold the component away from the pads, a pointy tip for my soldering iron, and a bit of careful soldering. Sorted. And just to be safe, I flow some solder onto the wires on the backside too. And the last caps, the 2 electrolytics, on they go. That's the last of the small components. After a good tidy up, it's time to put some silicon on this board. I do like a nice clean workbench. Each of the logic ICs is in its own bag, which is fun when you buy all of these chips and 100 packets arrive in a massive box, and you realise all of this is for a tiny ZX81. This first one got a bit mashed in the post, nothing a pair of snub-nosed tweezers can't sort. I'm going to solder all of the logic directly to the board and not fit sockets. It makes a neater and cheaper job, but to avoid potential problems later on, I want to run each of these through the Retro Chip Tester Pro to make sure they're all working well enough to pass this test. It adds a bit of time to the build, but it could save me a lot of time later trying to diagnose a dead chip. There's so much blue tack. I really should seek sponsorship. With all of the chips held in place with the blue stuff, I solder 2 pins on each IC. Then after checking they are all reasonably flat, I can solder all of the rest of the pins in one go. The RAM, ROM and memory are all getting sockets. Just because, don't judge me. The last bits to be installed are the connectors, 2 audio 3.5mm jacks for the tape in and out. An RCA connector for the composite video signal, and a USB Type B socket. An unusual choice, I think, but it's pretty hard to put the wrong polarity into this with a USB power supply. Before putting in the last 3 chips, I'm checking for resistance on the power rail. I really should have done this before installing all of the logic chips, but testing it now looks like everything is actually okay, and I should be safe to power this up. One downside of a USB Type-B power socket is if I want to use my bench power supply to watch for overcurrent events, I'll have to chop up a cable to connect it that way. But I think on this occasion, I'll just risk it and plug it in. See what happens. Oops, in my excitement, I bent a leg on this ROM. The socket is really stiff. Some contact cleaner will lubricate it and help the pins slide home. And it's done. Looks great too. I'm loving the white PCB, and the gold fingers on the edge connector give it a nice dash of sparkle. I've left the joystick port off for now. This motherboard will be going into a case, so putting the port inside here won't help me. That's something for another day though. There's some burnt flux residue on the back of the board which comes off nice and easy with a stiff toothbrush, some IPA and a microfiber cloth. I can't put this off much longer. Will it work? Of course it will. Yeah. I'm happy to see that friendly inverted K cursor. It's a relief I don't need to do any more troubleshooting. Or that's what I thought. In order to get a good image to show all of you that the picture quality coming out of this little machine was crisp and clean, I wanted to connect it to my capture setup. What followed was a whole day of hair pulling, which I can ill afford at this stage of my life. My usual RetroTink 2X knockoff couldn't lock onto the signal. This device has been giving me issues for a while now, on and off, but that's okay, I thought. I'll use the new one that Dave Steamy Briggs sent over as a kind gift for just such an occasion. I plugged it in knowing it would solve the issue and, well, it didn't. I even dug into my box of random devices and found my old AV to HDMI I used back at the start of this channel. And that worked a bit. It struggled to lock onto the signal and kept dropping in and out. I went searching for clues and discovered that the output, which for composite should be 1 volt peak to peak, was actually over 2 volts. I thought I must have put a component in the wrong place, and so checked the relevant resistors in that part of the circuit. Nothing looked out of place, and after peering at all of the solder joints, I gave the board another good clean with a stiff toothbrush, just in case there was a hair-thin strand of solder somewhere causing problems. I checked the voltage levels again, and lo and behold, there was some improvement. It wasn't perfect, but at 1.4 volts peak to peak, it was certainly closer. There must have been a problem somewhere that was now resolved. So I assumed this was the voltage level that this board was designed to output. And to be honest, the picture does look good on my screen. Maybe a tiny bit bright. I plugged it into the AV to HDMI box again and expected the problem to be now solved. But oh no, same behaviour. My next task was to get that voltage level down to something closer to the ideal 1 volt. These 2 resistors here at R50 and R55 are the ones that serve as voltage dividers, bringing the raw output down to a composite level. And on the schematics they were marked as 100 ohms each. The ones in the board were also 100 ohms. I did a swift calculation and worked out, almost all by myself, that I'd be better off with a 150 ohm in R50 and 75 ohms in R55. I switched these out and tried again. Well, the voltage is now down to a much friendlier 1 volt peak to peak, but testing with the AV to HDMI shows the exact same problem as before. It's not the voltage levels. At this point, I wondered if the signal being generated by the discrete logic ULA was a little bit too digital for an analog display. I found mentions on the internet of adding a capacitor between the video signal output and ground to smooth out the sharp edges would help. I soldered a 100 picofarad cap between these 2 points, which made no difference. I upped that to 470 picofarads, and again, no luck. I then examined the schematic and checked any components that were part of the video generation, and all of them were correct. I looked through the list of the other jumper settings available on this board and noticed there was one hiding down here, JP4, which is used for setting 60 Hz NTSC friendly video frequency instead of the usual PAL 50 Hz. Now, I'd heard somewhere these cheap video converters, which claim to be PAL compatible, are actually not entirely PAL compatible. Could it be causing this problem with both of these devices? Well, it's worth a try. I switched it on without changing anything and then jammed a pair of tweezers into the holes for that jumper. The picture, slightly larger than before, jumped onto the screen and was rock solid. All of that chasing just because these cheapo converters use a bit of a hack to be PAL compatible. A jumper soldered into place so I can choose between the different display options seems a sensible idea. And while I'm here, a couple of keyboard connectors. Well, now it's built and I have a display, I need to test a keyboard will work with this computer before attempting to build the next part of the project. This new ZX81 keyboard replacement sticker thing will do for now. A quick basic program to test if all is working as it should be. And that's how you do that. The next thing to tackle is to put this computer into a case that will make it more usable than the original black wedge. And to me, the best kind of case for this machine is one that allows me to use a mechanical keyboard. I really loved the keyboard on my Lee Smith designed ZX Metrum. I made a video about that build, and it would be really cool to have something similar here. And fortunately, someone has already done this part of the job for me. McIverdino on Printables took the original Lee Smith Metrum case and altered it to fit the ZX81+38. The original ZX Metrum had no spacebar, using the same layout as the ZX Spectrum rubber key, which is handy as the ZX81 has the exact same keyboard layout. But before we get into the keyboard, let's look at the new case which I printed on my Bamboo printer in pure white PLA. It's not a perfect print and I'm not a perfect 3D printer operator, but with a little light sanding I think it will do okay. Let's get this keyboard sorted so it gets a lid. As I mentioned before, the keyboard PCB I'm using is the Don Superfo ZX Spectrum mechanical keyboard, which you can find on PCBWay's shared projects. I'll leave a link in the description. Don't forget that Don gets a 10% kickback for orders through PCBWay. It's a great way to support amazing creators. This keyboard is not meant for the ZX81, and there are a couple of problems that will need to be overcome in order to use this one. First off, the placement of the connectors is spread out on either side. There are helpfully extra connector positions on the bottom edge too, but the real problem here is the ZX81 and the ZX81+38 both have their connectors next to each other, and in this case the connectors on the motherboard will sit pretty much in the middle of the case. I'm unsure at this stage if these cables I have here will be long enough, but the best way to find out is to solder them onto the board and see if they reach. Well, they didn't. The 5-way flex cable on the left actually broke the connector on the board. I need another plan. Ditching the flat flex cables and switching to some rainbow ribbon cables, I decided to make these removable at both ends with angled headers on the motherboard and on the keyboard PCB. I'll be happy I did this later on when I discover that the layout of the keyboard matrix for the ZX81 is different to the ZX Spectrum matrix. It took me a while to figure out where pin 1 was on the keyboard. It's not the square pad. And 2 of the lines on the larger connector needed to be swapped around. All of that made me scratch my head for a whole afternoon. Keyboard matrices confuse me. This 3D printed section fits over the keyboard PCB and the switches are placed into the guide holes. They seem a decent fit and I'm hoping not to have to do too much finessing of the switches, and holding this ruler against the top row shows they're all in perfect alignment. The only thing I need to make sure of is that the keyboard is pressed down firmly as I solder each switch. This gets harder the more switches I install, but I managed to get them all in place without any falling out. perfect. To my eye, these are in exact alignment. There are a few screws to be fitted on the back of this keyboard section to hold everything in place. I found these really nice red screws in an Amstrad parts haul I acquired recently. You can find videos about that on my other channel, More Fun Fixing It. A few more screws to hold the case parts together and the motherboard in place. It's now looking like a complete machine. The original ZX81 keyboard was a horrible thing I loathed, despite my deep affection for this machine. But at the time it was something of a revelation. Touchpads were not as common as they came to be in later years, and I regarded it as a futuristic way of interacting with the machine. Much nicer than those clunky old computers with their typewriter keyboards, horrible noisy things. But after living with it for a few months, frustration began to set in. The ZX81 is not the most responsive machine to program, requiring a young enterprising programmer to look at every key and then look up at the screen after every single key press to ensure it had registered, and they often didn't. But the thing that Sinclair had going for it in the keyboard stakes was the token keyword system. This allowed you to enter a basic keyword such as load or print with a single key press. None of your slow typing out every single letter of every word. This was especially important on this machine due to the terrible keyboard. It was hard enough to type in basic programs, but doing it on this without token keywords would have been a nightmare. Each key contains multiple commands which can be accessed depending on context or a modifier, and that's a lot of information to cram onto a keypad. But much as I like these plain white keycaps, which I think really do look the part here, typing in anything at all will be difficult without something on the caps to show what they do. I asked Retrofied Dan if he could do anything to help solve the keycap problem. He took a scan of a ZX81 keyboard and got to work. And what he produced is nothing short of amazing. These are the two keycaps I sent to Dan which he wanted for testing, and you can see he's performed a miracle. Dan needed to be a bit creative with the design of these. With the original layout, the keys have a landscape aspect ratio, but modern keycaps have a portrait shape to them. But I think he's done a marvellous job here, and unlike all of the other ZX Spectrum versions, these contain all of the info from the original keyboard. The vinyl that Dan used is semi-transparent, so you could use these on any colour keycap within reason. Obviously, black might make it a little bit tricky to see the print. Maybe you could do an inverted version. I did wonder if putting these onto the keycaps would be difficult, and was quite relieved that Dan had included some extras to practice with, as well as a second sheet if I really messed up. But it really couldn't have been simpler. I lifted a side of each decal off the sheet with a sharp knife, and then used a pair of tweezers to lift them and then place them onto the edge of each keycap. They're super sticky, but when I did mess up slightly a couple of times, it was pretty easy to lift them again and reposition. And like fitting a screen protector on your phone, you have to be a little careful with dust and hairs getting under the sticky side. Okay, how many of you were shouting at your screen about the bottom row being wrong? I knew all along, of course. Would I lie to you? And that really does top this build off. The ZX81+38 has many benefits over the original machine, including a composite output as standard, a power supply with a USB Type-B socket, probably the most robust of the USB connectors, configurable memory with 16 or 32K options switched with optional jumpers, and the ROM can contain 4 different versions which again can be selected with jumpers, opening up the possibility of this turning into the ultimate ZX80 just without the eggshell case. Speaking of the case, I'm not 100% happy with this one. The print quality on my Bamboo A1 was a little bit disappointing, and the colour is a very harsh, almost blue-white. The keys though are the exact right colour, and on advice from Dan at Retrofied, I've ordered some Bamboo Bone White matte PLA, which he thinks will be a far better fit. As you can see, everything is working as expected. Games load from the audio cassette input perfectly, and just like the original, my screen freaks out when loading from audio sources. You just need to start it off and hope for the best. But unlike the original, the ZX81+38 is very reliable loading from tape. So it's not the lottery we used to face back in the 80s. I have some additions to make later on. I want to add a reset switch and a joystick port here at the back. That should be fairly trivial, but for today, I'm going to call this complete. This was a great fun build, and the result is much better than I expected, with a machine I can honestly say would have been a dream machine for me back in 1981. And it's going to look great on my display shelves next to my ZX Spectrum Deluxe. Thank you for watching my video. Don't forget the other More Fun Fixing It channel, which you can find linked in the description. I make a lot more videos on that channel, so you can see much more of what I get up to here in my workshop. And if you like what I do and you'd like to support me, you can find a link to my Patreon also in the description. There's a free tier option to join, and also free trials for the higher tiers if you want to get a look at my upcoming releases. I'm going to put this to the ultimate test now, typing in a magazine listing. Wish me luck. Oh, so good.